Georgia Standard OA8 states, solve two-step word problems using the four operations. Represent these problems using equations with a letter standing for the unknown quantity. Assess the reasonableness of answers using mental computation and estimation strategies, including rounding. Students gain a full understanding of which operation to use in any given situation through contextual problems. Number skills and concepts are developed as students solve word problems. Problems should be presented on a regular basis as students work with numbers and computation. Students transition from two-step problems at grade 2, which involve only addition and subtraction, to grade 3 two-step problems, which vary in difficulty. In third grade, students gain the opportunity to maintain their addition and subtraction skills, as well as practicing third grade multiplication and division standards within the context of a word problem. Take a moment to solve this problem. What was your answer to the problem? How did you figure out which operation to use to solve it? Some students will actually see word problems just like this graphic. They read the first couple of words, then blur everything else out but the numbers and the key words. So just say no to teaching kids to use key words to solve word problems. As teachers, we must be careful not to highlight or modify a singular approach to solving any one problem. Moreover, research tells us that the use of keywords as a strategy for solving problems actually adds to our students' inability to solve those word problems. Keywords encourage students to strip numbers from the problem and use them to perform a computation outside of the problem context, much like the example on the previous slide. Instead of teaching keywords, teach students how to discover the underlying structure of a word problem. They not only have greater success in problem solving, but can also gain insight into the deeper mathematical ideas in word problems. Using numberless word problems allows students to focus on the meaning behind the word problem without worrying about the numbers. They are designed to provide scaffolding that allows students the opportunity to develop a better understanding of the underlying structure of a word problem. Students should analyze the structure of the problem to make sense of it. They should think through the problem and the meaning of the answer before attempting to solve it. Having them record their thoughts, what they wonder or they notice, allows time to deeply reflect on what the problem is really asking. They came up with questions they wanted to answer, which you see listed on the chart. After that discussion, students chose their own numbers to manipulate in the word problem and then solved for their unique word problems. Students then used the think, pair, share strategy to discuss their own problems. Later, I revealed the numbers and the questions. Here are just two examples of the students' math journals with their unique numbers. You can see one student chose to rely completely on the use of tape diagrams, while the other student used a mix of picture representation and tape diagrams or model drawings to discover their answer. This shows how students can create word problems and make sense of them on an individual basis, showing their mathematical thinking as they solve for their unique word problem. Instead of teaching the use of keywords, the use of making drawings or representations can be quite helpful for solving problems. Research indicates that using bar diagrams can help students develop understanding of problems and how to solve them. Students should use various strategies to solve word problems. Students are to identify arithmetic patterns and explain these patterns using properties of operations. They can explore patterns by determining the reasonableness of the solution to all problems using mental computation and estimation strategies. This first example is solving a two-step problem using a tape diagram or model drawing. Notice the next example, this student chose to create a model drawing where he drew 6 boxes and put the 9 cents in each box. Then he used a letter to represent his unknown. In this example, the student chose to use a pictorial representation for her problem, and this was her verbal description of her picture drawing. I divided the $25 by 5 to find out how many total bags she collected. There were 5 bags of leaves. Then I subtracted the 3 that she did on Monday, and that left 2 bags for Tuesday. This answer makes sense because I had already figured out that she should get $15 for the bags on Monday, and that left $10 for Tuesday. $10 would be 2 more bags. Whereas the second student showed her work completely with each step and used an unknown to solve the equation. In this slide, you can see students working collaboratively to solve word problems. While watching these videos, notice that my questions do not just address procedural rules and sequences, but they also probe the student's ability to make sense of the problem, and specifically how the quantities and operations relate to the context of the word problem.
We done a tape diagram, and we knew that there was, you know, that there was 3 groups. We just knew that 6 times 3 equals 8. 6 times 3 equals 18. And then we put 6 in each group, and then we minused out 1 group of 6 because he ate 1 box of grapefruit.
Grapefruit snacks. Right. Okay, so how many fruit snacks did he have left?
12.
12.
Go ahead. In one of the boxes, they crossed out some of the 6.
Do you understand why they did that? Why did they do that? Did you ask why they did that? You don't want to ask why they did that?
Yeah, I did.
Okay, well.
Why did you do that?
Because it says that he eats all the grapefruit snacks. So we crossed out 1 group.
Okay.
We did a tape diagram. We did total groups. We did a count die and 1 pack, and we crossed 6 out.
Okay, well, why do you have 4 in your tape diagram?
Because Miss Linda orders 4 packs.
Okay, and then why did you cross out the 6?
Because she only had 6 left.
So you crossed out the 6 left, and then what did you do, Jonathan, to figure out your 22 students?
We made the count by
So how'd you get 22?
counting it.
So what did you tell me what you counted?
28.
What did you do here? You had the 28 and you took away
6 equals 22.
There you go. Good job. Okay. All right, you guys tell us what you did.
We did a number line, but first we made a mistake because first we thought it was 21 and 22.
Okay.
But we made a mistake about that
Okay. How'd you know you made a mistake?
because we instead we put 6 in one group and the other was 7.
Okay. And when you're doing multiplication, what do you have to have?
You have to have the same thing it says.
Okay, good. Okay, so tell us what you did.
First we did 4 groups, and then we put 7 in each, and then we marked out 3 groups and 1 out of this group to make 6 left.
Okay.
And then we did a count by at the bottom to try to find it out.
Okay. So how many students does she have in her class?
28.
Okay, but you say she has 28 students, and they say she has 22 students. So what part did you forget to talk about here? 6 left. So if these were your 6 left, so these were your students, right? So how many students did you say this was?
22.
What was it?
22.
Okay. Is this sentence for label your tape diagram and find how many students are in Miss Leonta's class? Are there 28 students in her class? How many students are in her class? 22. Research shows students who assign verbal or written labels to quantities when modeling problem situations outperform students who do not use labels. The Thinking Blocks website teaches children how to model and solve word problems involving all areas of mathematical reasoning. In this interactive tutorial, children are introduced to 6 problem-solving models. The models help children organize information and visualize number relationships, walking them through the steps to solve 1- and 2-step word problems. They practice assigning and using labels to make sense of each problem. This is a task from the frameworks in Unit 3 called It Takes Two. In this 2-part task, students first work in groups to solve these 2-step word problems. Then those student groups will create their own 2-step word problems to present to the class to solve. The next 2 slides are from the frameworks task, Hooked on Solutions. In this task, students practice solving word problems. Then they work in groups to create their own 2-step word problems. OA8 is a capstone for the third grade student who has mastered basic facts and has a sophisticated knowledge base for the 4 mathematical operations. It is in this skill that they apply all their mastery into a variety of word problems that involve all 4 operations and solving for an unknown quantity. Students will use what they have learned to justify their answers as well. When students are given the opportunity to use concrete objects and drawings to represent multi-step problems, they are more likely to be able to use reasoning skills to find solutions. The focus in this standard is to have students use and discuss various strategies. Students should estimate during problem solving and then revisit their estimate to check for reasonableness.